Hi everyone, this is Mr. West, and today we're doing a Khan Academy tutorial on equation of a parabola from focus and directrix. There's a lot going on with this, so you probably should have a background in quadratics at a bare minimum. Really should know vertex form. I'll introduce that anyway later on in this segment, but I'm going to give you a focus crash course. So if you want to look on the left side of your screen, before we even look at the problem, let's kind of understand what focus and directrix is. So if we're looking at a parabola here, you can see the parabola's in blue. Its vertex, okay, in this case its minimum point is labeled as the vertex, and the focus and directrix are also shown. The directrix is that line, and I'm going to see if I can highlight this. So this line that extends, and the parabola opens up away from that directrix. And the focus is on the other side, and it's a point so that, see this yellow line? This yellow line indicates that the focus and the directrix are always the same distance apart from the parabola. And that's kind of a really cool feature that enables us to use like flashlights and radar and different parabolic shapes for a very specific purpose. And this is a really cool feature of parabolas, makes them pretty unique. But this is useful because we can see here, I drew this yellow line here. Those are equal distance away, but every point is. So if I went up here, that would be an equal distance away. And then here is an equal distance away also from the vertex to the directrix and also from the vertex to the focus. So if I go ahead and I label this point from the vertex to the focus as P, P is the distance called the focal length. So P is the focal length, and we're going to be using that at some point later on. So what do we do from here? Well, the focus is labeled here in this problem as 0, -5. So 0, -5 is labeled as our focus, and we have our directrix labeled as y equals -3. This is important, and I drew this over here. I always think it's important to draw kind of a diagram of what's going on. This will help you visualize it a whole lot better. So let's go ahead here. I have my directrix already labeled, and you can see I have it labeled as a horizontal line, and y equals -3 is always a horizontal line. X equals a number will always be a vertical line, and our focus is labeled there at 0, -5. So one of the first things we'll need to know, we know that our focal length is equal distance from the directrix and the focus. So what does that mean? It means our vertex splits the difference between our focus and our directrix. It's halfway in between. So here's our vertex. I know it's the same distance. How do I do that? Well, if I know the distance between the directrix and the focus is 2 units, which it is, y equals -3 and then y equals -5, then I know the focal length, P, will be equal to 1. So P is going to be equal to 1 here because it's a distance of 1 away, and 1 and 1 will equal 2. So my P equals 1. So my parabola is going to look something like this. Okay, and it's going to open down, and that's very important because we're going to use that later on as well. So P equals 1, parabola opens down, okay, and now we're essentially ready to complete this equation. So we have our equation kind of boxed right up here, and we're going to use the base form, which is y equals, and we're going to use vertex form, x minus h squared plus k. This is the point belonging to the vertex. This h and k belongs to the vertex. So our vertex point, hk, that's our vertex. So I know my vertex, I know what point that is. It's right there. My vertex is 0, -4. So I can go ahead and fill that in. I can say x minus, and then my x value is 0 squared, and then -4. Okay, that's the form. If you guys know vertex form, I have videos on vertex form if you want to watch it, but that's the basic bottom line for that. Now, here's the one wrinkle. The one modification that we have for focus form is normally there's a value A here in front that affects the stretch or whether it opens up or down. If A is negative, it opens down. So in this case, we know we need a -A. But for the focus, we know that it has a special relationship, which is 1 over 4p. So A equals 1 over 4p. It has that relationship where 1 over 4 times that focal length will be equal to A. So we can go ahead and do some calculations here. We know that a equals 1 over 4, and then we know our p equals 1. That's what we found out based on that distance. So p equals 1. Let me actually change it to purple. So we know p equals 1. That was the focal length that we found. So we know that a equals 1 over 4. 4 times 1 is just 4. A equals 1 over 4. Now here's the thing. It's not technically a positive 1 over 4 because it opens down. It's a negative 1 over 4. So if we have a focal length that's going down, okay, going down to meet our focus, then technically we need a negative focal length. So we'll call that negative 1, and we'll call that negative 1 over 4. So our final equation is going to be y equals negative 1 over 4 times x minus 0. In this case, we can just call it x squared minus 4. Again, our vertex was 0, 0, negative 4. That's our vertex. We had our a value from using the focal length, which we talked about in the focus crash course over here. And then we had, that's vertex form, and then that's it. We knew that it was negative because it opens down. So I'm going to type in negative 1 over 4, x squared minus 4. Let's see here. So I need to make sure I get this right. Negative 1 over 4, because my focal length was 1, times x squared. We don't need parentheses because it's minus 0, and then minus 4, and we're going to check it. And there we go. We got that one right. Okay, now this one. I didn't mention this in the first part, but this is a little bit different. Write the equation of parabola with a focus at 2, 2, and a directrix at x equals 8. Notice how it says x equals 8 instead of y equals 8. So the first thing I'm going to do is I'm going to graph this, and I just need a rough sketch. So my rough sketch is x equals 8. That's my directrix. I'm going to just kind of label it over here. X equals 8. My focus, I'm going to make that in green. That's at 2, 2. So I'm going to go 2 over, 2 up. Let's just say it's right there. It doesn't have to be perfect. I want a rough idea where this goes. So that's 2, 2. So I know my focus is somewhere in between, or sorry, my vertex needs to be somewhere in between, and I know it opens up to the left because it has to open up away from the directrix. Now, you're looking at this and you're probably thinking, whoa, this opens up to the left. Yes, parabolas can open up left and right also. So this one is in the form of x equals y squared. So this is a little bit different, but this is possible, okay, with the directrix on this side and the focus on the left. Now, because it's opening to the left, that means it's going to have a negative a value. So negative a value if it opens to the left, and a positive a value if it opens to the right. So let's go ahead and stick to the same principles, which we know the vertex is halfway between the focus and, I think I said vertex, right? The vertex is halfway between the focus and the directrix. So if this is x equals 2 and this is x equals 8, then I know the distance between those is 6, so I know it's 3 away. 1, 2, 3, and this one's 1, 2, 3. So if I go 3 down and 3 up, I arrive at the same point, which is 5, 2. Now the y value stays the same. Okay, it stays in line with the axis of symmetry. That's another feature of parabolas. It has this axis of symmetry where the parabola kind of mirrors itself on either side of that. So this axis of symmetry keeps the y value at 2 because that focus is at 2, just as an FYI. So we have a couple features already set in stone here. We know it's going to open up like this. Okay, but now we need our focus, our focal length. So that's p. Our focal length is p. So p again is that distance between the focus and the vertex, but also the same distance from the directrix to the focus. Either way, we calculate it as 3. We took the total distance between the focus and the directrix, which was 6, and we divided by 2 to get our focal length of p equals 3. So we're basically ready here, okay? So what we're going to do here is we know that our a equals 1 over 4p. Now, I need to make a modification to my p because it goes to the left, okay? My focus is to the left of my vertex here, so it's negative. It's going in the negative direction. I always just like thinking of that. If it goes to the left, it's going to be negative. Go to the right, positive. Same thing or up and down. Up is positive, down is negative. So I know this is going to be 1 over 4 times, I guess, a negative 3 So that's 1 over negative 12, or negative 1/12. So I know my A equals 1 over 12, but that's negative. Okay, so I'm going to keep that in mind. I'm going to use that later. But I need to get into my base form here for a horizontally faced parabola. So a horizontally faced parabola is going to have y minus k and then plus h. See how it switches like that? So again, it's the same thing. We have our vertex right here. So our vertex is hk. So we're going to just follow the same principles. We're going to have y minus 2 squared plus, and then my h is 5, so plus 5. See how it kind of switches? The h and the k switch for horizontal parabola versus the vertical parabola. So that's just something to keep in mind. Yeah, but you got the bottom line of it. That's the important part for this exercise. And then we know that a equals negative 1 over 12, and that's it. That's all we got. We have our vertex labeled, we have our a value, and we have x, and we're ready to go. We're going to type in negative 1 over 12. Okay, I might need to reference it again. So let's get negative 1 over 12. Okay, and then I have my parentheses, x, actually y minus, sorry, meant y. And what I say, 2 for that. That was my y value of my vertex. And then my x value, I think it was 5. Yep. And that's plus 5. Oh, forgot the squared. Don't forget the squared. That'd be easy points missed right there. All right, so got that one. Moving on to the next one. Write the equation of parabola. I'm going to go a little bit faster this time with a focus at 7.2. Again, no matter how fast I want to go, I'm always going to draw a picture because I think this helps me visualize it. I mean, you guys can do whatever you want to do, but it doesn't take much to get an idea of what's going on. So then I have 7.2. That's over here. We'll call that 7.2. That's my focus. Now I need to find my distance. That's where I'm going to start, is my distance between these two. So my distance between these two, it's 2 there, and then I have 2 there. So look, my focus is going to be 2. And I know it's opening up because it needs to open away from my directrix. So I know my a is positive. So I have a couple features I already know about. I have a equals 1 over 4 times p. My p is 2. And it's going to be positive because it's opening up. This parabola is opening up away from the directrix, so 1 over 8. So I got the first part, 1 over 8. Now I just need to label my vertex. So my vertex is labeled as, well, I need to find that point. It's going to be halfway between these. So if I go up 2 and down 2 from the focus and up from the directrix, I'm going to get to the point 7, 0. See, that's why I think, you can see it's kind of missing there. There we go. That's why I think it's very important to draw a picture. It really helps you. You don't have to do as much math if you draw a picture. I'm a pretty visual person myself. So I know my x value is 7 squared, and then my y value is 0. So my k is technically plus 0, so I don't even need to have that on there. I just need 1 over 8 times the quantity x minus 7 squared. So we're going to go ahead and write that in. Positive 1 over 8. Okay, then we have x minus 7. Okay, because that's where the vertex was, squared. My y value was 0 for the vertex, so I don't need to add anything, and I should be good. And there we go, last question. Of course, they're going to give us a horizontal one to finish up with. So write the equation of parabola. Let's go ahead and draw a picture first. So we have our picture. We're going to draw a directrix. That's x equals negative 4. And then our focus is at negative 7, negative 5. So it's going to be down here. One thing I know right away, it's opening to the left. So my a value is going to be negative. Okay, so I know it's a negative a value. Now I need to find the location of my vertex. I find the location of my vertex by first finding my p value, which is the distance between this, the directrix, and the focus divided by 2. Well, I go from negative 4 to negative 7. That's a distance of 3. So the distance there is 3. That distance is 3. I need to divide that by 2, and that gives me a focal length of p equals 1.5. Now, keep this in mind. P is going to be a negative 1.5 because it's opening to the left. Okay, so this is not a super easy one, but we can still do it. It's just going to have a decimal. That's not a huge deal, okay? I might as well find my a value by going 1 over, and then I do 4 times negative 1.5. Let me go ahead and put that in print. There we go. Negative 1.5. Okay, so I just need to solve for a. A equals, and if I times 4 by negative 4 times negative 1.5, that's going to give me negative 6. So 1 over negative 6. So negative 1 over 6 is going to be my a. I'm going to use that later. Now I need to know my vertex. So my vertex is going to be the halfway point between these. That's where my p-value is important. Essentially, I just need to go 1.5 from that point, or I'm going to go from the focus. So I'm only changing the x value here. So I'm going to do negative 7 plus 1.5. My y value stays the same for my vertex. So I'm going to keep that negative 5, and that's essentially my vertex right here. So I have negative 7 plus 1.5. That gives me negative 5.5, comma, negative 5 as the location for my vertex. Okay, so that's that point there. And you can double check that by adding, or actually subtracting in this case, 1.5 from negative 4, and you get the same thing. You get my x value as negative 5.5. So how does this work? Well, I already said that it's going to be in the form. This is vertex form for horizontal parabola. We have a times y minus, in this case, k squared plus h. Well, my h is negative 5.5, and my k is negative 5. So this one's a little tricky. I'm glad we ended on kind of a difficult one. I'm going to go ahead and start. Well, let's go ahead and write it out first. So we have x equals, I already know that's negative 1 over 6. Okay, got my a value. Y, now it's minus 5 for my k. Take a look. So a minus 5 for my k. So that means I do a minus 5. It's going to be plus 5. Okay. I didn't mean to say k there, but yeah, my k is negative 5, so it's going to be y minus a negative 5, which is plus 5. Now, plus h. My h is negative 5.5, so I need to subtract 5.5 at the end because it's moving to the left. It's in the negative x direction, okay? So that's my equation. I just need to type it in. I'm definitely going to have to reference it because it's kind of complicated to remember. So I need a negative out in front. Almost forgot that. Negative 1 over 6. Then I have my parentheses, y, I think it's plus 5, I think I said, squared, and then minus 5.5. I need to double check that just in case. Always better to be safe than sorry. And I think I got it. Let's check it. And we're good. We finished it up. I hope this was helpful for you. Make sure to check out my other videos, especially on vertex form of parabolas. I have all the forms of the different parabolas, standard, factored, and I have tons of other videos, so make sure to stay tuned to those next time right here on West Explains Best.